Hey, this is Mr. Preston back with Simplifying Radicals Part 2. Now last time we simplified radicals when we had numbers. Today we're going to be simplifying radicals when we have variables or letters and numbers. So let's start off with the square root of b to the fourth. Okay, so the couple different ways you can approach this. First way I like to look at this is square root of b to the fourth. Okay, that breaks down into the square root of b squared times the square root of b squared. So once again, I'm looking for pairs of the same thing. So the square root of b squared is simply b. Square root of b squared is simply b. So I have b times b, which is b squared. So that's one way to look at it. Another way to look at it is square root of b to the fourth is simply b times b times b times b. How many pairs do I have? I have two pairs. So I have b squared as my final answer. Now I have b squared down here. And I want to check to see if I'm correct. So the opposite of a square root is, well, squaring something. So this is my final answer. And if this is done correctly, then when squared, it will be b to the fourth. Okay, well, let's square b squared. So b squared is b squared times b squared. Now, if you remember from Algebra 1, all we have to do here is add our powers. 2 plus 2 is 4. So b to the fourth is what we had up there. So yes, b squared works here. Let's say we have the square root of r to the sixth. So what you'll begin to notice is when I have an even power, the number of pairs I have is simply that power divided by 2. So r to the sixth, well, 6 divided by 2 is 3. Or I could even write it out. R times r, r times r, r times r, 1, 2, 3. So 3 pairs. R cubed. How about d to the 12th? D to the 12th is d times d, 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 d times d. So how many pairs do I have? 1, 2, 3, 4, 5, 6 pairs of d's. So d to the 6th. And once again, a double check. If I squared d to the 6th, that would be d to the 6th times d to the 6th. Add the exponents. D to the 12th. Yeah, let's say we have some odd powers. X to the 7th. I'm going to write out all my x's. Okay, how many pairs do I have? 1, 2, 3 pairs of x's. And how many do I have left over? Well, I just have one pair. I just have one left over. So the reason I put the square root of x is, remember, the whole goal here is to get pairs of the same number. 2 times 2, I have a pair there. The square root of 4 is simply 2. So I had 3 pairs. Remember, whatever we have on the outside, that's how many pairs we have. Our goal here is to always, when simplifying a radical, make our radicand, which is what's under the radical, as small as we can get it, as simple as we can get it. So I actually have one x left over, which is why it ended up here. What if I had x to the 5th? It would be x times x, x times x, x. So I have x squared, one left over. How do we double check? X squared, so remember whatever we have out in front means we have a pair of these. So I have a pair of x squared, so that's x to the 4th. Then one under the radical, so x to the 5th. All right, let's say we get x to the 210th. All we have to do here is divide our power by 2. We have x to the 105th. How do we double check? Square this. X to the 105. Oops. X to the 105 times x to the 105 is x to the 210, because we add our powers with exponents. Okay, so let's put this all together. Let's say we have the square root of 27x squared y to the fifth. Okay, so let's end this. And when you have multiple things as the radical, easiest thing we can do is separate everything. So this reads as the square root of 27 times the square root of x squared times the square root of y to the fifth. So the square root of 27 times the square root of x squared times the square root of y to the fifth. Step one, all I did was I wrote these separately. Now what I'm going to do is simplify each one. Remember, when simplifying a radical with a number, I'm going to look for my biggest perfect square. That's one way to do it. So biggest perfect square that goes into 27 is 9. So I have the square root of 9 times the square root of 3. Do I know the square root of 9? Yeah, well, simply 3. This is 3 square root of 3. X squared, remember, take your power, divide by 2. How many pairs of x squared do I have? I just have 1. So this is just x. Y to the fifth, how many pairs of y to the fifth do I have? Well, I have 2 with 1 left over. Y squared, square root y. Last step to bring it all together. So I have 3x y squared, square root of 3y. How do we check? Whatever's on the outside we have a pair of. So a pair of 3's is 9. 3 times 3, 27. Check. X squared. Check. Y squared times y is y to the fifth. Let's do one more, and I think we should be able to do simplify any radicals that involve numbers and or variables. Say we have the square root of 8, x to the sixth, y to the third. Same thing. Square root of 8, the square root of x to the sixth, square root of y to the third. So remember, first step, separate your radical into however many parts there are. Here there's 3 parts. 8 breaks down to the square root of 4 times the square root of 2. Square root of 4 is 2 with a remainder of 2. X to the 6, I have 3 pairs. Y to the third, I have y with a y left over. Your final step, bring it all together. 2xy, 2xy. So all the stuff that's in front of the radical I put together, 2xy. And all the stuff that's under I put together, 2y. Now why do I do that? Because all of this stuff is being multiplied. That was simplifying radicals part 2.